recording. And I will start this presentation. So welcome everybody who is interested in a deeper dive into the MESA-DER functions. This is a workshop, so I will be speaking the whole time, but if you can get your questions ready or put them in the chat, that would be fine. And I'm hoping to leave enough time at the end of the workshop to actually respond to some of the questions. So let's get started. I am going to do just a quick introduction to MESA and the MESA-DER. Hopefully most of you have seen the previous workshops, but I'd like to just have an introduction. Then I will go over interoperability, which is really critical in the world of DER because there's so many utilities and there's so many DER types and devices and companies. So they need to be able to interoperate. I will then go getting then down into some of the gorier details of MESA-DER. I'll introduce the spreadsheet, its contents and the layout, including then number 4, the management of curves and schedules. This is can be confusing if you haven't tried to really understand how it works. Then I will get into the testing and the profile conformance using DNP3, and then just one slide on membership information, and then we'll get into questions. So a brief introduction to MESA Alliance. MESA is the Modular Energy Systems Architecture Standards Alliance. It is an industry association comprised of utilities and technology providers. This is a current list of most of the MESA members. Some are just listed on our website, but this picture is useful to see. And as you can see, Austin Energy, your utilities, LADWP, Duke Energy, SMUD, Snohomish, of course, Southern Cal Edison, Salt River Project, SDG&E. So there are a lot of utilities, as well as, of course, the vendors, Doosan, STEM, of course, Trimark, and many of the others. It's really important to have a mixture of utilities and vendors. So what is MESA's mission? MESA's mission is to accelerate the interconnection of distributed energy resources through the development of interoperable communication specifications. So MESA-DER's focus is on using DNP3 protocol along with the IEC 61850-7-420 data model that provides the interoperability to meet the IEEE 1547 DER interconnection functions, as well as IEEE 2800, which is the standard for the larger inverter-based resources, the bigger plants, and all of these include energy storage requirements, which they hadn't originally, but this has again been one of MESA-DER's focuses. So how do we look at this? It's important to first try to see the context and the architectures that we might be looking at. In the first workshop, I went through this in great detail, but in this workshop, I'll just simply say the level 1 are the DERs themselves, including storage, PVs, and electric vehicles, very important. They all live in various facilities, the blue here, and they can have some kind of energy management system or power control system. There are many terms for it, but it's basically the ability to manage the DERs locally at the facility. And the facility could also be a plant, so that it could have even greater capabilities than just managing the DERs. It can manage the whole site for providing services. Also, there are aggregators, very important. The yellow and brown are the utilities. So this is the distribution utility. This is the transmission utility. And up at the top is the market. So it's really important to see this as a set of interactions amongst many stakeholders, so that it's not just, say, the utility to a DER. It's really interactions between aggregators and plants and the facility management systems, the EVs, the electric vehicles, as well as batteries, etc. So it is important to see the big picture. Okay, what is MESA-DER? This diagram shows how it was sort of created over time. We had the 61850 data object model, edition 2. We used that to come up with a preliminary specification for energy storage. Then we also took the DNP3 protocol and applied it, and we came up with a DER, MESA-DER specification, an electronic spreadsheet for testing, and I'll get into that a little bit more later, as well as the DNP3 app note, which really picked up on the details of DNP3, as well as the data objects that we were defining from 61850. What we're now doing is turning this into an IEEE standard, 1815.2. So we're just in the pre-balloting stage. We're having the working group go through and review it, but we hope to get to balloting in September. So I welcome anybody to join in the balloting of this document. So what's in MESA-DER? What are the functions? So we have the 1547 functions that are tested via UL 1741 SB. And you can see here the list of the 1547 functions. But we also have a number of additional MESA functions because we set out first to work on storage. And so it was important to have functions that reflected storage requirements, such as charge discharge. You have to be able to charge it as well as to just discharge it. And we have peak power limiting, generation following, load following, automatic generation control, and a number of others, including scheduling. And I will get into the scheduling requirement more later on. So you can see that we have quite a number of additional functionalities in the MESA-DER because particularly storage needed to be able to have these functions. Okay, interoperability and communications. There's often a question asked as to why is there more than one protocol being required or being used? Why can't we just have one protocol and it does everything we need? And the fact is that there are definitely different strengths and weaknesses of different protocols. Uh, and at the moment, there is no way that we can go and select a single protocol. So looking at this communications architecture, as opposed to sort of the DER architecture, this is showing the communication requirements. So for instance, up at the utility level, at either the transmission or distribution operation, SCADA system, if they're interacting directly with a plant, they want to use a protocol that is meant for that process. And in that case, DNP3, as well as maybe 61850, can be used in very direct real-time monitoring and control. So this is one reason why the DNP3 is extremely important. However, there are other parts of the communication architecture. If the utility is just interacting with an aggregator or interacting with a facility, but not directly monitoring and controlling it, maybe indirectly or just occasionally, then there can be other protocols used that are perhaps more applicable to that situation, where there are gateways in between for security reasons, for privacy reasons, etc. And in that case, the IEEE 2030.5 can be used, as well as DNP3 and 61850. And then it is those aggregators or facilities that actually monitor and control the DER. And often they use SunSpec Modbus or Modbus in general to actually interact with DERs. So as I said, it's important to recognize that there's really needs to be more than one protocol, because they have different types of strengths and weaknesses. So which ones are we talking about? And it really is these protocols. It's the 61850, the DNP3 just by itself, the MESA-DER spec, which is now, I need to update this slide, which will be 1815.2. Then there's the IEEE 2030.5 and SunSpec Modbus. But the thing that I want to point out here is you can see this is a stack, and the stack has different parts to it. And if you start at the bottom, you can see that there is media, wire, coax, the cloud actually. But if you look at the protocols, they first have the transport areas. Many of them, most of them use TCP/IP. And then they have what is called the application layer, or the services and syntax layer. And all protocols have that, because that's how you tell the end device what it is that you want to say. Whereas just sending it over TCP/IP just simply gets it there, but it doesn't say what it is. But then above that are these information models. This is really an important concept, that you have to have a data model to say what it is. Is this a voltage measurement? Is this a frequency measurement? Is this an enabling a volt bar function? What does it mean? And this is where, as you can see, the protocols in this group have some kind of information model associated with them, except for DNP3. And that's why we in MESA said, okay, we've got to add an information model that's focused on DER, and we add it to DNP3. So we're using the same DNP3 down here, but we've added the information model to it. And all of this comes from the 61850. Even these other ones are sort of based on the 61850 data models. All right, so we have that as sort of the background. And now I'd like to get into some of the MESA-DER spreadsheet contents and layout. First of all, as everybody knows, the DER can be very simple, just a simple PV system with a bunch of panels and one little controller. Or it can be quite complex with multiple batteries and multiple inverters, and then some solar panels, maybe included directly or maybe not included directly and connected at an AC level. There are a lot of meters. There's sort of a controller of the whole thing, and various places to monitor all of the different pieces, all the different parts of this, including when we go out to the grid, the point of common coupling, the PCC. And one of the things that's also really critical is this concept of state of charge or usable energy versus actual energy. You never want to actually drain the battery or the storage system completely. You should always leave sort of a reserve at both ends, either at the top or the bottom. And so there's sort of a different area or a different part of it that is the actual usable energy. And then there's a way of determining the state of charge. In some cases, the vendor will simply say, this is my state of charge. I'm not going to tell you how I figured it out, but this is my state of charge. Or you can measure it and come up with a value. So what is in the MESA spreadsheet? First of all, there's all of the data. We've got nameplate data, configuration data, some of the operational settings, counters, alarms, states, state of charge, state of DER, some protection items. So that's the basic information. Then we have some of the functions, which are like the connect disconnect function, cease to energize, voltage ride through, frequency ride through. And then we have a whole bunch of functions. I'm not showing all of them in this slide, but we have the active power functions, we have the reactive power functions, and then we have additional types of functions. And as you can see from here, what we're doing is showing where these are defined. And over here on the right-hand side, this is the DNP3 point range. So this shows exactly which DNP3 points are being used for these different values. So this is at a high level. So we know that AI is analog input 0 to analog input 23 are nameplate data. And analog output 0 to analog output 2 includes configuration data. So what we have here is a table that sort of shows the overview of it. But what I'm now going to get into is what the spreadsheet itself looks like and how we're actually using it. So this may look confusing, but the first set of data is the SCADA type data. And I mentioned nameplate and configuration, the functions. Then we have curves for the functions, system meter, and some extensions. We then have a gap, which is part of how DNP3 works. DNP3 used to sort of require, or almost require, that you start at 0, so DNP 3.0, and you just work your way up to 1, 2, 3, 4, 5, etc. So that makes it difficult for it to be interoperable, because one person's number 1 might be somebody else's point number 97. So what we've done is we've defined very precisely the different points that are going to be used for each of the values. So again, this is more of the overview side of this. And we have, just to be clear again, there are 4 types of DNP3 points that we're talking about. We're talking about binary output, that's the BO, binary inputs, the BI, AO is analog outputs and analog inputs. And what we've done is created an index that shows exactly where these points are located, what DNP3 points there are. So the configuration and control points start at 0 and then go on up. But once you hit the scheduling points, we've just said they're going to start at 2000. So we'll have the schedules all start at points 2000. And then there'll be a gap at 3000. The gaps are when we know that they're going to be more points. We're going to be adding points. So we have gaps there to allow us to add points for future extensions. And then we have historical points, and they'll start at 5000. So we've left a whole bunch of room here to say, well, we probably are not going to use all of them, but we never know. So we're just going to leave room there. And then we have gap 3 at 30,000. Then we allow vendor points to start at 50,000. And essentially, we stop at the 65535, which, if anybody knows, is the highest number that you can get for this size. So this is what we have and how we try to work it. So again, this is an overview of it. Now I'm going to show you the details. So here is binary output starting at 0. And it is the system set lockout state. And it shows what it means when it's 0, because remember, these are the binary points. So it's either a 0 or a 1. And it has a unique string name. It's a 61850 name. So that using that, we tie it to the IEC 61850 data models. And therefore, if anyone comes along and says, well, I've got, let's say, B03, so binary output number 3, system permission to start, that's this dgen PRM con. And that's what it always is. And everybody who uses MESA or the 1815.2 will have the same meaning of binary output number 3. It will always be system permission to start. And this is really important. This is what provides the interoperability, that we have a unique string that is tied to a specific DNP3 point index. And it has, what is the state? What is the value, the meaning of the value when it's 0? What is the meaning of the value when it is a 1? So then we have some additional information. If you know anything about DNP3, you have both a binary input and a binary output. The output is what the master station does. And the binary input is what the DER, in this case, DER provides back to say, oh yeah, I got the system lockout state, and now this is my lockout state. So there's an association between many, but not all, BOs and BIs. We also just have something here for the purpose, just makes it easier to read. And then we also had, is it included in 1547? And as you can see down here, BO3 is included in 1547. These others are not. And, you know, this is one of the reasons we felt that it was so important to have this kind of document that includes more than what's in 1547. Okay, here's another example. I won't go through it in gory detail, but this is now analog input. This is coming from the DER to the master station. And again, we can see the DNP3 points starting at AI0, AI1, etc. It just literally goes on up the number chain, and it has a unique 61850 value. Again, coming from the 61850 data model. As you can see, there are more of these. These are some of the nameplate values. It also includes in the AI the minimum and maximum, and in the multiplier and offset, and what kind of units we're talking about, like volts, watts, VARs, VA, amp hours, watt hours, etc. So there is even more information than in the analog part of the spreadsheet. So remember, this is a spreadsheet. It is literally an Excel spreadsheet. And it is part of the 1815.2, so that it will be possible for you to take the spreadsheet, because it is much more electronically friendly than a PDF file, to use for populating your DNP3 database. So now let's take a look at some of the functions, because what I had before was, you know, nameplate and configuration information, but now we have also the functions. And here is active power limit. So you can see, maybe a little small on your screen, but I'll tell you that this is AI 142 through AI 149. So these are the active power limiting data objects. So there's one for priority, one for enabling a time window, enabling a time ramp, ramp time, a reversion timeout period, a signal meter ID. So where are you measuring the limit? Is it at the PCC? Is it at the point of common coupling, or is it a point of connection, or where is it that you're measuring it? And that's what this data point is. Then there's a reference input. You know, what is the actual value that you're reading? How many, if you're limiting active power, you need to know what the active power is at that particular meter. And then here is the set point. I want to limit it to, you know, 10 kilowatts or whatever the value might be, and you know, and so that's the set point, and the generation set point if you're doing also charging and discharging. Remember, this is valid for storage and electric vehicles for that matter, as well as for things like PV. So that's why there's a charge set point and a generation set point. So, and again, it has the unique 61850 name. In addition, in the MESA-DER spec, or the DNP app note, which is becoming 1815.2, there are steps associated with each of these functions, so that it gives you, it doesn't mean that you have to. In fact, you can see here the optionality is optional until you get down here is required, but it gives you a sense of what you might need to do to actually implement this function. So that's really important. Each one of the functions has this set of steps associated with it. Again, now this one I'll guarantee you can't read. Don't expect you to, but if you want to get the slides later on, which will be sent out, you'll be able to look at this in more detail. But as you can see, it contains a lot of the data points, and this is for frequency watt or Droop. And it includes, again, these diagrams that are related in this case to the 1547, which is this last column here. Another function which is not 1547 is peak power limiting, load following, and generation following. They're very similar. It just depends upon what they're monitoring in order to do the function, which is why they're typically sort of used together. So as you can see, they're now functions that go beyond the 1547 functions. And I think this peak power limiting and load following, generation following is particularly important because it will allow the capability of, let's say, a storage device to follow, and let's say it's down here, the blue storage consumption here interacts or monitors the PV and reflects what's happening. So the PV is going up here and there, but the net result, because the storage is now consuming power, in this particular example, the actual net output is just this green line here. So that this allows you to manage your PV plus storage much more directly. A new function, which is synthetic inertia, we have added this, but it is a new function. So it is included in this extensions area. And one of the things that we're hoping for is to get input on, when we go to ballot, get input on this function to say, yes, it includes all the data points that we need, or no, it doesn't include all the data points that we need. The other thing that is important to recognize is that the DNP3 app note and now the 1815.2 standard, the IEEE standard, also includes the sort of gory details of what DNP3 structures need to be used for the binary input, output, analog input, and output. Because there are different ways in DNP3 to actually manage these various types. And, you know, this is what the DNP3 experts will look at and say, okay, I need to follow exactly what is in these tables on how to actually implement a particular DNP3 point. So that's important. We've covered all the bases for providing not only the data points, but how the data points are structured in DNP3. Okay, management of curves and schedules. One of the difficult parts in both curves and in schedules is that you can have different numbers of points for let's say a curve, because this is the curve point. You can have a curve that consists of 4 points, or a curve that consists of 50 points, if you want a really well-defined curve. And we found that although there's some curves where it sort of has a diagram where there's only 4 points, like the volt-var curve, in reality, it would be much better to have maybe 10 or 12 points for these curves. And so what we've done is allowed the ability to have a variable number of points. In fact, we've left 100 points for them, probably more than anyone would ever need, but nonetheless, what we've done is say you can have any number of points so long as you tell us, and down here, this AI 330 is the curve number of points, and it includes then all of the other information from the spreadsheet. But there are different curves now that show, which one are you talking about? Are you talking about the volt-var curve? Are you talking about the frequency watt curve? Are you talking about temperature mode, the voltage ride-throughs, the frequency ride-throughs? So these are enumerations of the curve type. And then over here is the set of curve points associated with that curve. The same is true with schedules, conceptually. We've left room for about 100, well, actually 250 schedules with up to 100 points per schedule. Okay, that's an awful lot of data points. So we've done something which I'll show you in a moment, but just quickly first on the schedule structure, we've got, again, just like in the curves, we've got a list of the type of schedules, including charge discharge, coordinated charge discharge, AGC, volt-var. So you can now schedule any one of these functions. And it has the identity, the priority, very important to have a priority of a schedule, because some may be very much more important than others. The function being scheduled, the start date and time of the schedule, the repeat interval. So is it going to be repeated daily? Is it going to be repeated weekly? Is it going to be repeated annually? What is the repeat interval? What is its validation status? Because it's been, say, received, a good schedule has been received, but has it been validated? So there's a number of things there. Again, as I said, the number of points in the schedule up to 100, and they consist of a time offset from the start date and time. So it's the time offset from that. And then the second point is the value. And then we do it again, time offset and value. And then it goes on for up to 100 points. We've also included the ability to schedule day of the week. So you can have a schedule that says this just runs every Sunday, or this runs Monday through Friday, or this runs on Wednesday and Friday, whatever grouping that you want. So it's a very flexible type of scheduling capability. But you remember I said that would consist now of thousands and thousands of points if we just said that every single point is in the DNP3 list. And we said that doesn't make sense. It could have 120 schedules, 250 schedules, and 100 points each, just crazy. So what we've done, instead of having 1 point per item, we have a mechanism with a selector capability. So we have sort of a space in the DNP3 set of points that says, here is all the points that you need for one schedule. We also, same as for curves, but I'm going to talk about the schedule. So here is one set of points that's for one schedule. And then you use that one to say, I'm going to select which schedule I want to provide in the first place or modify if you're modifying it. And so you say, I want to select schedule number 103. And then that would bring out that schedule, number 103, into the DNP3 area that's for the schedule. You can then update that schedule and it will then be stored again back in the outstation. So this takes some work in the outstation, the DER in our case, to say, okay, I've updated this particular schedule, now store it back into there. And now I can go and select a different schedule to update, and it will then work. So that's the mechanism that we use for entering and updating schedules. So we can have these large numbers of schedules and all of that without using up all the DNP3 points. It's just this ability to do this selection. So this is an example where, again, we have a schedule where we have the priority. You can have multiple schedules all operating at the same time. I'm not going to go through all of this, but what you can do is look at it and you can see that, you know, in some cases, this means execute only on weekdays. It repeats every 7 days. It starts July 11th, 2021, etc. So you can combine schedules, and this is an interesting example of that, where you can combine different aspects. So you've got to have, say, an upper limit for the DER itself, and it's the highest priority because you can't go beyond what the upper limit of the particular DER is. That's its limit, its physical limit. It can't generate more than that. But you might have a peak power limit that is much less than that. So, or different from that. And then you might do some generation following and then some active power smoothing to just sort of smooth out the transitions between times when you set the time to start now, and this is the value. Now, you know, an hour later, you start with a different value, but you might want to have something to smooth it out. So it's complex, but quite possible to utilize the scheduling capability to really manage your DERs. Okay, I'm going to now jump to the testing. Just one of the things that we are now working on is testing both the MESA-DER profile communications. This is the spreadsheet. If you think of it, we're calling it the profile communications, but it really is the spreadsheet. You have to test that to make sure that a vendor has implemented that correctly. You also have to test the functions. What we're doing is using the 1547.1 for testing the 1547 functions, but we're also developing, I'll get to that, the MESA-DER functions tests. So the testing for those. We've also partnered with UL, UL will be doing managing the testing, the NERDL testing and certification program for MESA, because we're really just a small organization. We couldn't do it ourselves. but UL has agreed to take that on. And then we know that there will be factory acceptance test as well as commissioning in the field. So we recognize there'll need to be first profiling, communications testing, and then the functional testing. There are a lot of details in that as well. We had a workshop that went through the details of the testing and certification process. So this is strictly an overview of that. And one of the things that I will add here is, okay, how is the MESA spreadsheet for the profile conformance testing done? We've added some columns, so these bright yellow columns here, where the equipment under test can add whether they want to be tested for this particular function. In this case, we've got the charge, discharge, active power function. You know, do we want to test for that? Is it there? Is it in there correctly? And if the minimum and maximum values that they want to test for are different, that's also included. This comes from a Triangle MicroWorks tool that we asked to have developed. So I'll get now to the functional testing for the functions. We think of our work as primarily that there will be some kind of plant control system, PCS, and there will be testing of that for the 1547 functions, but also the additional functions that are in MESA. And then we're thinking that MESA-DER will be used for testing the plant control system or the PCS or the whatever energy management system, whatever it wants to be called. And we also recognize that the plant control system will probably use Modbus. We're hoping that it'll be Sunspec Modbus via MESA device, but we recognize also that oftentimes the Modbus is more specific. So we have a standard for Modbus. We're hoping people use it, but I haven't seen that happen too often. But this is the testing plan, again, with the UL managed testing. So I'm now going to just have one request for people, which is that we are working on the functional tests for MESA-DER for the ones that are not in 1547.1. We recognize that we need to have input from MESA members and any testing experts to help us complete this MESA-DER testing document. We've sort of used the 1547.1 as an example of how to do it, but we really need experts to help us finalize that. So anybody on the call that can help out with that, that would be greatly appreciated. Okay, one final slide here on MESA membership. I'll just provide you with this information and you can look at it and see if you want to join MESA, and hopefully some of you will. And we'll then get on to questions. And I will open up the questions that I have received so far. Okay, and then we'll go to general questions. Okay, Michael Cohen, which DERMS vendors support MESA-DER? That's a very good question. And what I'd say is that there are a number of vendors who are providing the power control systems that would be used to manage the DERs, like TriMark. ABB is working on it, and Doosan, who's a vendor of storage devices. If you're referring to DERMS from the perspective of the utilities, I don't know that there's any DERMS vendors, but remember that utility SCADA systems, almost all of them use DNP3. Now, they may not use DNP3 with the 1815.2 or the MESA-DER names, but adding the names should be pretty straightforward if they're going to use their SCADA capabilities. So I don't know if that answers your question, but and I will also, if you want to speak, go ahead and chime in.
No, that's it. That's good. Thank you.
Okay. Okay, next, Alan, great question. It will be interesting to know if they take advantage of the data model with their internal data structures rather than just mapping generic points. I'm definitely hoping so. Can you provide an OTA? I'm not sure quite what OTA stands for. I know there are a lot of acronyms.
Over the air.
Oh, okay. Over the air. Okay. Message view of the DER curves sent from the utility to the DER devices for all curve switch points list. That would imply going down to the DNP3 actual points. What I would suggest is you talk to somebody who's actually implemented this, and if they're willing to send you a copy of the DNP3 messages, I would be, I think that would be great. In terms of, you've seen the structure from the point of view of the spreadsheet plus the DNP3 structures. So that's what it would look like, but I don't have an implementation here. Is there any interest in putting the spreadsheet that is even more machine readable like JSON? And the answer is yes. We had a long discussion in moving to 1815.2 whether we would convert the spreadsheet into JSON, and we made some trial efforts of that. However, the thing that we found was that we want to get version 1 of 1815.2 out the door as fast as we can. And therefore, we wanted to make as few changes as possible from the DNP3 app note and from the spreadsheet that we use for that. So we decided that we would send out 1815.2. As I said, we now have it planned for balloting in September. And then what we will very likely to do, if particularly if there's interest, which I believe there is, we would go to a next version of 1815.2. And one of the things we'd likely do is convert the spreadsheet to probably JSON. That remains to be seen, but that was one of the reasons we sort of held off on doing it was, well, there are different ways to do it. And so we said, okay, let's just leave it as a spreadsheet for now. Okay, and then how does the user know which units are used if the AI can support 2 different units? And the answer is there's a setting. One of the settings, which I didn't happen to show on this diagram, that says, are you using amps or watts? So that's really just one of the settings. Okay, so that's the set of chat messages. We have 3 minutes left. who would like to ask a question, and just open it up and see if you have a question to ask. So, was this understandable? We're always ready to answer more detailed questions if you have them, by email. And you're more than welcome to do so. But any other questions? Any volunteers to help with the functional testing document? That's one where we've come a certain distance, but we would really like some particularly experts on testing, to say, oh, you need to add this or you need to add that as part of a test. So we're very much hoping for some additional input there. Okay, I've got a question in the chat. Which IEEE subcommittee is sponsoring 1815.2? It's the Power System Communications Committee, and the group is P15. So P is in Paul, 15. And we have bi-weekly meetings. I think the ones in the summer are going to be a little sparse, but we will definitely start really finalizing what goes into the balloting by September. So you're more than welcome also to join that group, because that's where we discuss some of the details on, what are we going to do next. Okay, any final questions, thoughts? If not, I think we can close this session with half a minute left to spare.
Thanks, Francis. Very informative, as
Good,
usual.
I'm glad.
Thank
Hopefully
you.
that'll help
Great stuff.
people.
Looking forward.
Okay. I will see
Yep.
you all next
Take
time,
care.
whatever that might be. Okay, bye.
Thank you.